So last class we had discussed about basics of electrochemistry, where we discussed about what is the hydrogen economy all about. That's the starting. Then we discussed about conductivity in solids. We discussed about conductivity in liquids. We also discussed that a liquid which conducts is known as an electrolyte. Just trying to get your memory refreshed. A liquid which conducts is known as an electrolyte. A liquid doesn't conduct is known as a non-electrolyte, and a solid which conducts is known as a conductor. A solid which does not conduct is called an insulator. In solids, the conductivity is due to the flow of electrons, and electrons flow in a direction opposite to the conventional direction of current, whereas in liquids the conductivity is always due to ions, and there are two types of ions, cations and anions, cations being the positive ions and anions being the negative ions. We also said that a battery never supplies electron. A battery is like an electron pump when the current flows in a solid. But whereas when the current flows in a liquid, we have. Before that, we also discussed about how to check whether a liquid conducts electricity or not. So you can have a bulb, and if you think that a bulb is not glowing and still you have a doubt, you can put an LED. LED glows on a weak current. And apart from that, you can also use a magnetic compass with a wire wound around it. If the compass deflects, that means there is current glowing, because every electrolyte may not conduct as good as the other. So the electrolytes which conduct very good are known as strong electrolytes. The electrolytes which do not conduct very good nicely are known as weak electrolytes. Okay. Now, so the standard setup, okay, if I talk about a standard setup, now this will be very common as we go ahead in the chapter. We will be always finding in this chapter that we will have a setup something like this, which is known as our electrolytic tank. This is our electrolytic tank, usually made of glass, because glass is non-reactive. Inside this electrolytic tank, we will always have an electrode. So we fill it up with electrolyte, that is the liquid which is going to conduct. Okay, and then we will have two electrodes inserted inside it. So we have two electrodes, and the electrodes are usually can be metallic rods or can be carbon rods in the form of graphite. Okay, there are two electrodes, and these electrodes will be then connected to the respective positive and negative terminal. Now say the red is always an indicator of what we call as positive. So this is connected, say, to the positive terminal. So this is connected to the positive terminal. I can't draw a black, you won't be able to see. So I am drawing it with the green. The green is supposed to be the black one. So this is the negative terminal. Remember, children, the type of supply that we give out here is not the supply that comes in your home. Your home has got alternating current. This is always known as DC power, means direct current is supplied from here. Now this is connected to so this becomes my positive electrode, and my positive electrode will be named as anode, and my negative electrode will be, from here everything is important. Okay, all those fairy tale part is gone. This is known as cathode. Cathode is the negative electrode, anode is the positive electrode. Now, as I told you, when you talk about ions, now this might lead you into a little bit of confusion. When you talk about ions, ions are of two types. You have cation and you have anion. And I told you that when you write cation, you write the T in this manner so that you can detect that the cation is a positive ion. When we talk about electrodes, okay, when we talk about electrodes, now this is what you have to understand. This is a little bit important. Okay, when you talk about electrodes, how to understand which electrode is what. Generally, people will say cathode is the negative electrode. It's not like that. Okay, the proper definition, look, electrodes will be of two types, cathode as well as anode. So people will say cathode is the negative, anode is the positive. Don't go by that judgment always. We shall say cathode is the electrode where reduction takes place. यहाँ से चीजें are tough, so please pay attention. Okay, where reduction takes place. Anode is the electrode where oxidation takes place. Okay, where oxidation takes place. This is which we have to understand. Reduction means, reduction is always rig. Reduction means gain of electrons. Gain of electrons. Okay, and anode means oxidation, which is oil. Oil means loss of electrons. Children, first have this concept. Okay, don't initially go with negative and positive. Right now, the setup that you are seeing right now, so far we are talking everything about a thing called electrolysis. Now this is also very important. Understand electrolysis. What is electrolysis? A process in which look at my drawing first, then it will be easy for you. I'm not drawing something a diagram, I'm drawing a mind map, so try to understand. Electrolysis is a process where electricity is an input and you create chemical reaction. Have you understood this? Electrolysis में electricity is an input and you will create chemical reaction. Is this clear? Whereas in this same chapter, we will study, or maybe in other chapter we'll study another process where we will be talking about something like a cell, where cell means, suppose the batteries that we use, which are there in our remotes and other things, those are not electrolytic cell. Batteries and other things will have a similar electrolytic tank setup. There we will have chemical energy. There we will have chemical reactions, and the chemical reactions will be the input which will give output to electricity. आहिरी पिछले 5 मिनट से तुम मल्टीटास्किंग कर रहा है. So no, what I'm saying, you have to pay attention here. What I'm saying is very, very, very important.
Yes.
No, you'll make a mistake. That's what I'm saying. Electrodes are of two types, cathode and anode. I have not put plus and minus to it. Then you will tell me, sir, you have already put a plus and a minus out here. Why are you saying you didn't put? There is a reason to it. Please understand. मैं अभी भी plus minus नहीं डाला हूँ. उसका reason क्या है? Cathode को plus करके मत याद करो. Don't remember cathode as minus or plus. First is, what is cathode? Cathode is an electrode where reduction reactions will happen. What are reduction reactions? Reductions are reactions in which gain of electron will happen. Go by this definition. Anode is a reaction where there will be loss of electron. Have you understood? Now the diagram that you are seeing, you would think that this is the यही diagram हर एक चीज में आएगा. No, there will be similar two diagrams. What I am trying to say, बच्चा, I am trying to say this diagram you will see in electrolysis. This diagram you will see in something, this process which is also known as a electrochemical cell. Electrochemical cell in your desi bhasha is something which is known as battery. समझ में आ रहा है? Let's see the left hand side first. Electrolysis. In electrolysis, electricity is an input. आप electricity देते हो and chemical reaction is an output. Have you understood? Whereas in a battery or electrochemical cell, chemical reactions will be the input and electricity will be the output. Be very, very clear about this thing. Now we will say what happens in cathode and anode. So far that you are studying, we are studying electrolysis. We are right now not studying electrochemical cell. What is an electrochemical cell? जैसे आपकी गाड़ी का battery, your car batteries and all, those are all electrochemical cells. There, chemical reactions give rise to current. Current is an output. What you are studying now is called the chapter of electrolysis, where electricity is the input. Have you understood?
Yes.
In this case, when you see electrolysis, then when you set up a electrolytic tank, okay, when you set up an electrolytic tank for electrolysis, you can set up an electrolytic tank here also. एकदम देखने में same होगा, लेकिन एक चीज गड़बड़ हो जाएगा दोनों में. Okay, what is the गड़बड़? In this side of things, cathode is always the negative terminal and anode is always the positive terminal. Please do not go that cathode is forever negative. No, यहाँ पे उल्टा हो जाता है. यहाँ पे एनोड हो जाता है नेगेटिव और कैथोड हो जाता है पॉजिटिव. So don't goof up. As long as you are studying electrolysis, the formula is very simple. CN stands for Cartoon Network, AP stands for Andhra Pradesh. आपको जो ठीक लगे आप. I used to remember like this in my childhood. You remember the way you want. In our days we had this channel called Cartoon Network. So Cartoon Network stands for cathode as negative. But not always, huh? Only when you are studying electrolysis. Electrolysis नहीं पढ़ रहे हो तो cathode negative नहीं होता है. In fact, if you open up a electrochemical cell, there you will see cathode as the positive. अब वो गड़बड़ हो जाएगा. The battery, okay, the battery that we have, let's say for example, these are the batteries inside a remote, the cells. In these cells, cathode is the positive not negative, because in these chemical reactions are giving rise to electricity. Are we fine so far? Okay. So this thing is something that you should remember. So if somebody tells you define electrodes, electrodes are the metallic rods or rods made up of graphite from carbon that are dipped in the electrolyte, whose main purpose is to guide the external current into the electrolyte. They guide the external current. देखो बाहर का जो करंट है उसको गाइड करता है. They guide the current and again take back the current. Okay, that is the job of the electrode. How many types of electrodes are there? There are two types of electrodes. What are they? Cathode and anode. Define cathode. Sir, cathode is the negative electrode. मैं लड्डू मिल गया वहीं पे. Cathode is the electrode at which reduction happens, irrespective of which type of cell, electrolysis or electrochemical. Reduction ही होगा उसमें. And while you deal with an electrolysis type of cell, the cathode is the negative electrode because reduction happens at negative. But when we deal with the electrochemical cell, cathode becomes the positive because reduction happens. बच्चा एक और चीज जान के रखिए, कैथोड में हमेशा ही रिडक्शन होगा. यहाँ पे रिडक्शन होगा, here यहाँ पे रिडक्शन होगा. And anode में always oxidation will happen irrespective of which type of cell. Only the name switch. Is this clear between cathode and anode? So don't define them with negative and positive straight away. First define what is an electrode, what is a cathode, and then say that cathode for this type of cell will be the negative electrode. But the perfect definition is cathode is the electrode at which reduction happens. Fine. Okay. Now we also discussed something called, that whenever electrolysis happens, there is a movement of ions. So let me again draw what you call the electrolytic tank, which we will be keeping on drawing. Okay. So let's say right. This is a standard electrolytic tank, and as of now, children, we will be only talking about the process of electrolysis. We are not generating current. We are using current to create chemical reaction. Okay, so let's see this reaction once again. So these are, suppose, my carbon rods which are behaving as my electrodes. Okay, and I connect this, and say suppose I have connected this one to the positive terminal and I have connected this one to the negative terminal. Okay, so obviously in my case now this becomes the cathode and this becomes the anode. Okay, and this is my nice little electrolyte. This is my electrolyte. So as soon as you pass electricity through here, there will be formation of ions. There will be formation of ions because this electrolyte is going to split up. This is going to split up and this is going to split up into ions. Now question arises, sir, does only the electrolyte split up? Well, it depends. You may say your electrolyte is something like say H2SO4, which is an acid, and this is what we will study very much in detail. But I told you all acids and all things should be in aqueous mode. They should be with us. That means if you have an acid, please do not rule out the little bit of water also. So the acid will split up into ions, the water will also split up into ions. Splitting up to ऐसे ही होता है, ठीक है? So if you take only water, no sir, only water will not work. Acidified water will work. So there will be split up of ions. So we will have ions and these ions will be positive and negative. Okay. Sir, is there only one type of positive and one type of negative? No, the story becomes very interesting. We'll see different type of negatives, different type of positives. So we generally say that the negative ion will travel towards the anode because unlike poles attract, and the positive ions will travel towards the cathode. यही होता है, ठीक है? अब इस चीज को we are going to study this under three different things. We will see what are, because we know we have talked about electrolyte. So what are the type of electrolytes we have seen? We have seen electrolytes can be acids, electrolytes can be bases, electrolytes can be salt solution, and then somebody might say, sir, what about water? I would say no, water does not ionize. However, if this water is acidified, this water will ionize. Now, how do you prove that these ions actually move? Well, there is one experiment and demonstration in your book also. So rather than me drawing it, so what I'll do, I'll just paste the drawing so that it becomes easy for us to understand. Some of the what do you call, beauty of carrying the class online. Okay, let's see. Okay, now let's see this setup. Okay, let's see this setup. This is from your book. Okay, let's see this setup and try and understand what is happening out here. Okay, the ions go. So this is a nice example. What we are doing here, we are taking a salt. Okay, this example talks about a salt called, sorry, copper chromate, CuCr2O4. Okay, CuCr2O4. This salt is known as copper chromate. This is a lovely experiment, copper chromate. And copper chromate में क्या रहता है? The oxidation state of copper is 2 and the oxidation state of chromium is 6. That's why they say, if you want to test it, we can test it. Let's see how to find out the oxidation state. Copper's oxidation state is 2. So let's do the mathematics. आपको अपने आप पता चल जाएगा. Overall, it should be 0 neutral. Chromium we don't know. Let's put chromium as X. Copper is 2. We have got 2 of chromium. Oxygen is how much? 4 into minus 2. This everything should give me 0. Okay, so it becomes 2 plus 2x minus 8 is equal to 0. So how much is it? 04. Just 1 minute. Okay, chromium example. Okay, not Cr2. That's what I just made a mistake. 1 minute. Huh? It's CrO4. Hang on. Chromate is the ion. 1 minute, huh, children? Yeah. 1 minute. Okay, it's not Cr2O4, it's CrO4. Okay, CrO4. So 2 into x. Now see what is the value of x coming up as? X is coming up as 6. That means chromium is at 6. So when you write this salt, your book will write it like this: copper 2. 2 stands for that the oxidation state of copper is plus 2, and then they will write chromate. And this will be written as 6. That means chromium is at plus 6. Chromium is at plus 6. Okay. And if this dissociates, how will this dissociate? Cu plus 2, CrO4 negative 2. This is how this fellow is going to dissociate. Okay. This is an example. What we are studying here, why are we doing this study? We are doing this study to prove actually, ये जो हमने यहाँ पे लिखा था ना, that ions will respectively move. Who told you, sir, ions will move? I said, okay, let's do an experiment. So what is the experiment we did? We actually in this experiment took copper 2 chromate as a salt. So copper 2 chromate को कैसे लिया? ये हमारा copper 2 chromate है. Okay, this is my copper 2 chromate salt. And over this salt, to make it a little bit acidic, what did we do? Acidic because you have to make it नहीं तो आपका dissociation नहीं होगा. So this is dissolved in dilute hydrochloric acid. So this color of the salt is usually green. Okay, the color of the salt is green, and that's why you see this portion. Sorry, you see this portion green in color. See, this portion is all green in color. Now when you pass electricity, it will split up into two forms of ions, copper and chromate. Copper is always blue in color, and this one is yellow in color. Now look at copper. This is a positive ion, so this should go to the negative electrode. Negative means it is an electrolytic cell, so it should go to the cathode. Now look, where is copper going? Copper is slowly traveling as blue towards the cathode. You can see this in your lab. And chromate is yellow, yellow, dirty fellow. So negative should go to positive. ये positive की तरफ जा रहा है, देखो. This experiment tells you we are not studying electrolysis of copper chromate. We are doing this experiment to understand how the ions move. ठीक है, तो कैसे हमने स्टडी किया? हमने एक सॉल्ट लिया. What is the salt? Copper chromate, and this is known as copper 2 chromate 6. It tells you that what is the oxidation state of copper, what is the oxidation state of chromium. Well, that is not important and relevant here. Still I showed you. And ये 2 भी नहीं रहेगा. हाँ, sorry, ये 2 नहीं रहेगा. So from this we get to know that the salt, which was green in color when it was diluted with acid, after electric current was passed, ions were formed. What ions? Copper ions and chromate ions. So where did the chromate ions go? The chromate ions means basically chromium and oxygen. उसमें भी oxygen तो evolve हो जाएगा. Chromium. The chromium ions went towards the negative electrode being yellow, and the copper ions went towards the chromium ions went towards the positive electrode, which were yellow, and the copper ions, which are the positive ions, went towards the negative. Is this clear? So now tell me one thing, if you have any doubt on any of these terms, please stop the car and ask me right now. I'm going to write some terms and you check whether you have any doubt on any of these. Yeah, check each of the term. If you have any doubt, we'll check them so that we understand it absolutely clearly before going ahead. क्योंकि इसके आगे से चीजें थोड़ा सा, I won't say tough, they're all easy, but अगर आपका ये knowledge clear नहीं है, you will be limping. So check. If you think there is any doubt on anything, I'm here to explain again. I'm giving you 2 minutes break. I'm sitting in front of you. आप देख लीजिए ये सारा चीज आपको समझ में आया है कि नहीं.
Sir, can you just talk about ionizing the level?
Ionization. Okay, very good. So if you take an ionic product, okay, an ionic product, what can be an ionic product? Say a salt, okay, and basically you have to take a salt solution, or you have to take something called molten salt, which we will discuss again in the next section. So I'm taking salt solution, which is NaCl, sodium chloride, typically in your kitchen, and I have dissolved it in water, so I write it as aqueous. This fellow, once it goes into water, it ionizes to form sodium ions and chloride ions. Similarly, if you take an acid called H2SO4, not concentrated, but this is dilute. Why dilute? Because in dilution it will be in aqueous mode. Water has to be present. Then it will split up into how? It will split up into 2H plus, that means you're getting two positive charges, so you should have two negative charges on sulfate ion so that it neutralizes. If you have an acid like say HCl and you make it dilute, then it becomes H plus plus Cl minus, and if you say have a base like sodium hydroxide, again it should be dissolved in water, it will ionize to sodium ions plus hydroxide ion. This is known as ionization. So we always deal with ionic products because ionic products undergo complete ionization and you will see good amount of current flow. Whereas in the same case, if you would have taken something like say acetic acid, which is there in vinegar, this is the formula of acetic acid, this is also going to ionize. How? This will ionize as CH3COO minus and H plus, but this is a organic acid, and an organic acid is considered to be a weak acid. So we will say there will be only partial ionization. ये अच्छा current नहीं देगा. And again combination will happen. This will rebound back. The ions will dissociate and again they will combine to form back acid. Hardly, see in higher, if you want to learn one step higher, then we will introduce a term called alpha. ये हम बाद में देखेंगे. Alpha is known as degree of ionization. How much do you ionization? And this will give you a clear link why ionic compounds give you better electricity, current flow. Here alpha is only 5%, means if you have 100 molecules of acetic acid, only 5 of them are going to ionize. Here in ionic product, this is greater than 95%. Alpha is greater than, or alpha is almost 95% to 100%. So suppose if you take salt solution, is readily going to ionize. So the current flow will be very good. Whereas if you take acetic acid, or you say take any organic acid, say from apple you have taken malic acid, from milk you have taken lactic acid, they're not going to ionize that good. Usme light bulb jalega, I don't know, maybe an LED will glow and that current flow will be very feeble. So in this discussion, in this chapter, when we discuss, you will never see that we are discussing with organic acids like say malic acid or say citric acid, lemon wala acid, or we are talking about, we'll not discuss those. We're going to discuss about with only guys who will be excellent supporters for electric current. And who are those? Those will be guys like very good bases, okay, strong bases. Sodium hydroxide is a very strong base. Strong acids like HCl, H2SO4, and very good salts like NaCl. These are going to ionize in a very fantastic manner. Check any other term that you need a explanation out of 13, right? What I said about electric current is that two things you should understand: that the direction of flow of electric current is opposite to the flow of current in solids, okay, flow of electrons in solids. And one of the function is that when you look at this electrochemical cell, you should understand one more thing very clearly, that from here to here, okay, whatever is the flow of current, it is negative, okay, so it is negative means the electrons are getting repelled in this direction, okay, and then the electrons again come up in this direction. So here in this part of the circuit, it is the electrons which are doing the magic, but in this part of the circuit, that is this from here to here, it is the ions which are doing the magic, and that is completing the circuit. ऊपर वाला पोर्शन बच्चा ये क्या है? ये कंडक्टर है. These are wires. So here electrons will do the magic, and this is electrolyte. So here ions are doing the magic. Ultimately the electrons. And how is my current going? Current always flows from positive to negative. I told you current is always from positive to negative, opposite to the flow of electrons. Clear? If there is any other thing, have a look, and then we can go one step forward. Are we done? Yeah.
Sir,
Yes, tell me. Don't hesitate, क्योंकि आप
Yeah.
यहाँ से आधा information में जाओगे, आप लुढ़कोगे आगे. It's not going to be easy. Yeah.
Sir, can you explain the difference between cathode and anode again?
हाँ, cathode and anode. अभी क्या करें आखिर इसको? Should we paralyze her or not for cathode and anode? So I'll tell you one thing. This is being recorded. I will share the Zoom file also, but the Zoom file is only one thing. You should download it. There's enough discussion in the first 20 minutes that I did. You will be able to understand once you see the recording, okay? Cathode and anodes are two electrodes. Always remember, the cathode and anode are two electrodes. Their job is to guide the current into the circuit and take the current back from the electrolyte. Cathode is the electrode where always reduction happens. Anode is the electrode where always oxidation happens. Remember, this type of cell setup which you are seeing, this type of cell setup can happen in an electrolysis case or in an electrochemical cell, that is a battery. She is again frozen. Okay. So can't do. Let's go.
Sir, can you hear me?
I can hear you. You're frozen. I told you. Or else you take the class from the room where your router is. That's why your problem. Or you have to do cabling job and get a cable, internet cable in your room. नहीं तो repeater आपको काम नहीं देगा. See, I'm sitting in my bedroom right now, one of the bedrooms. I have got a specific router for this
Sir,
room.
we have a mesh. Sir.
मैश करो या जो करो नहीं जाता है. आदमी का हाथ में ही 2 बार एक्सरे होता है, एंड यू आर थिंकिंग वाईफाई विल कम. डिफिकल्ट. ठीक है, चलिए. So we go to the next section, and our next section will be, now we will see electrolysis of different things. First we will see salts, and salts we will see as salt, acid, all these we will see one by one. तो चलो एक एक करके चलते हैं, and then we will understand. So as per your textbook, we are now done for the first part, and some of the questions comes up. I think all questions we will be able to answer. Which of the following will conduct electricity? Strip of copper metal, solution of sugar in water. Well, that's not going to conduct electricity. Aqueous sodium chloride, yes. Mercury, yes. Dilute hydrochloric, yes. Melted sugar, no. Sugar is not going to conduct electricity. Which type of I and R electrolytes? Which type of which are electrolytes? So from 1 to 6, this you can answer. Why is solid? Okay, these are all easy questions. So our next job is electrolysis of molten ionic compounds. As I told you that the compound must be in solution, aqueous solution or molten. So our next topic is electrolysis of molten ionic solution. Okay, so what the name itself tells us very clearly, you are going to have an ionic what you call ionic, not solution, ionic compound, sorry, solution अभी नहीं है, solution इसके बाद, ionic compound. So the name itself tells me I am going to have an ionic compound, and this ionic compound will be in molten state. So question arises, will it conduct? Yes, it will conduct. An ionic compound always conducts either when it is in molten state or when it is in aqueous state. For example, NaCl, the salt solution that you have at your home. So the salt solution will salt. If you take the salt container from your kitchen and try and pass electricity through it, listen my question very carefully. Will the salt conduct electricity? No, because the salt is in solid form. Unless it has got some water embedded in it, you don't know. It might have some moisture. Like on rainy day, the salt on your table will become soggy. Have you seen? If you sprinkle salt on a rainy day, the salt doesn't sprinkle or flow very nicely because it's soggy. But if your salt is as crystal dry as a new pack of salt and you put 2 probes inside it, nothing will happen. So we are going to take an ionic compound and we are going to melt the ionic compound, that is heating will be there, and we will see electrolysis, and molten ionic compounds will conduct. The ionic compound as per your syllabus in study will be lead bromide, PbBr2. Okay? So our setup starts with PbBr2, and what I'll do, I'll pick up the diagram from the book itself. This will save our time and it will make you easy to understand. चलिए इसको देखते हैं अभी. Right, one minute. Okay, so let's see the setup here. Right, fine. So again, same sort of setup. We have got an electrolytic setup. Let's understand it properly. We have got plus and minus, direct power, DC current, or not DC current, DC power. DC itself stands for direct current. So DC is being flown inside the electrolyte. What is my electrolyte? My electrolyte, let's take it like this. My electrolyte in this particular experimental setup is Pb lead bromide, and lead bromide in molten form. This is my electrolyte, and to keep it molten always, I am always supplying heat to it. Okay, this is my electrolyte. Let's look at our electrodes. Our electrodes are carbon electrodes in the form of graphite. Okay, and how does the electron come? देखो children, मैं इसको annotate कर रहा हूँ. This is my negative. So all the electrons will be repelled from here. The electrons are repelled because this is a solid conducting wire. So till now electrons will do the magic. And then we will discard the tumbler portion, and then again when you come, the electrons are getting attracted. Where are the electrons getting attracted? They are getting attracted to the positive side. Okay, this is how the circuit goes. Now inside the tumbler, electrons don't have any role. I should not say tumbler, I should say the electrolytic tank. Tumblers, the electrons don't have any role, so there will be ions. अब वहाँ का game को देखते हैं. The game, we're going to watch that game out there. So what is happening inside the electrode? So we understood so far now that there is something called cathode and there is something called anode. ठीक है बच्चे, एकदम आराम से समझो. यहाँ पे डाउट है तो पूछा करो. कैथोड क्या होता है? कैथोड is the place where reduction will happen. Anode is the place where oxidation will happen. Reduction means rig, oxidation means oil. This means loss of electrons are going to happen here, and at rig, gain of electrons will happen. Gain of electrons. Have you understood? Right? So my electrolyte is what beta? PbBr2. PbBr2, now again Nidhi, same your question, will ionize due to the flow of electric current. That is when this switch will be turned on. Okay, when this particular switch will be turned on, the switch is turned on, this is going to ionize, and it is going to form lead ions, and it is going to form Br negative ions. So there will be 2 Br negative ions. Br2 means Br minus Br minus. समझ में आया इतना? ठीक है? we can immediately term this, as our cation. No doubt about that, cations are always, and this will be our anions. Samajh mein aaya? Okay. Now we have got two graphite electrodes out here. So what I'm doing is that the diagram is there beside you, but still I'm drawing two graphite electrodes. These are my two graphite electrodes, and I name them as, I tag one as negative and I tag one as positive. I make sure I'm not naming cathode anode now. Okay, so I'm saying this being the negative ion, will एकदम जाके attract करके इसके तरफ चला जाएगा, and bromine being the positive ion, and bromine being the negative ion will start to go to this. How do you get to know? Well, we get to know bromine will always be a reddish brown gas. Reddish brown. Typically imagine a rusted iron. If it was coming out, if fumes were coming out of a rusted iron, fumes of rust, what will be the color? The color will be typically brown reddish color. That brown reddish color, bromine as a gas will start bubbling out from that positive. Now whether it is anode or cathode, we will ourselves prove. We know वो anode है, लेकिन कैसे anode है देखेंगे. Okay, and this will happen. Now what is the definition for cathode? The definition for cathode is where reduction happens. So I go one step further and I try to see what we call as half reactions. These half reactions are very important. Half reactions means half reactions will actually show you oxidation, show you reduction. And if you add the half reactions, then you actually get the complete electrochemical reaction. We will get the complete electrochemical reaction. So let's see the half reaction now. Okay, now lead. Okay, we had PbBr2. PbBr2, you are saying that PbBr2 became Pb2 plus Br2. Okay, let's write it like this, plus Br negative. Now this is the complete reaction. Let's see what actually happened. Lead became lead plus 2. Now put your brains, okay, and start thinking. Lead became lead plus 2. इसका मतलब क्या होगा? लेड के ऊपर दो पॉजिटिव चार्ज never goes out. It's always the game of electrons. Remember, protons neither go out, protons neither come in. It's always electrons. If I got positive charge on my forehead, I was neutral. It means I must have lost electrons. Yes or no? I must have lost electrons. 2 electrons I have lost, right? And okay, and Br, this bromine becomes bromine minus, means bromine has to, 1 minute children, and bromine has to accept an electron, then only bromine will become Br minus. And if we have got 2 of the bromines, we accept 2 electrons, so we become Br plus Br. Have you understood? And if you actually now add up these two equations, if we add this equation also, you see the 2 electrons will cancel the 2 electrons, so you actually get PbBr2 is actually giving you Pb plus 2 plus Br minus plus Br minus. Have you understood? You're getting the same reaction. Have you understood? This is how the ions are, but this is not the electrochemical reaction. Now what is happening here, we will see. Now here we said, now Br minus is not a stable product. Bromine is a stable product, and please understand children, 2 atoms of bromine will combine together to form 1 molecule of bromine. Okay, so have the understanding clear now. We said that the electrolyte has now dissociated into 2 ions. One of the ion is Pb plus 2, and other type of ion is Br minus, and you have another Br minus. These are the ions. Have you understood? Now, what is oxidation? Oxidation is loss of electrons. So what happens? My fellow bromine has 1 additional electron, and this bromine fellow becomes Br and loses that electron. This is called oxidation, is loss of electron. Where does oxidation take place? Oxidation always takes place at the electrode which is known as anode. इसीलिए एनोड को पॉजिटिव माना गया है. समझ में आ रहा है? तो एक ब्रोमीन पैदा हुआ, लेकिन हमारे पास तो बेटा दो ब्रोमीन थे, तो another bromine also lost its electron and it became Br. This bromine and this bromine combined as Br plus Br and it got evolved out as Br2 as our bromine gas. I'll explain again, don't worry. This is what is happening at anode. Now let's see what happened at cathode. We had a cation whose name was Pb2 plus, lead ions. Pb2 plus gains 2 electron. My question is, where did it get these 2 electron? Well, one of the electron was this released by bromine and one of the electron was this. It gained 2 electrons. This is gain. Okay, gain means rig. Reduction is gain of electrons. And where is this gain of electron happening? At this electrode. So this must be my cathode. Ab samajh mein aaya? Now I start writing this reaction once again and I will write, let us see. We had PbBr2, this was our electrolyte, okay, and this electrolyte was in molten state. When you passed electricity, this ionized as Pb2 plus, aqueous obviously, okay, we'll not write aqueous because there's no water, plus 2Br minus. Is it fine if I write? Right. So ऐसे क्या बोलूं, जैसे बोतल में पानी है उसी तरह I brought lead bromide in liquid form and lead bromide को लाके ही electricity pass कर दिया गर्म करके. Now lead bromide in liquid form means molten form and उसको electricity pass कर दिया, it dissociated into 2 ions. Now we write like this: reaction at anode. Anode is the electrode where always oxidation happens, irrespective of which type of cell you are, electrolysis or electrochemical. Electrochemical is battery, वो बाद में पढ़ेंगे, अभी हम electrolysis पढ़ रहे हैं. Electrolysis और electrochemical, anode में हमेशा oxidation. Oxidation बोलते ही आप क्या करते हो? OIL. Oxidation is loss of electron, means here that reaction will take place which will lose electron. तो किसके पास electron ज़्यादा है? इसके पास है. So 2 Brs come, right, and they lose their electrons as Br one atom, Br one more atom, and lose 2 electron. Have you understood this? And these 2 Br again combine and form what is known as bromine gas. This is the gas, and this is what is getting bubbled out at anode. Sir, can I see it? Absolutely. This will come out as reddish brown vapors. Reddish brown. समझ में आया? तो ये प्रोसेस को हम क्या बोलेंगे? इस प्रोसेस को हम बोलेंगे ऑक्सीडेशन. To write it in more better form, I'll write 2Br becomes Br2 and loses 2 electrons. So this is OIL, loss of 2 electrons. Children, are you clear or not? Now 2 electrons lost means nobody can lose electrons. Electron बच्चा थोड़ी है मेले में खो जाएगा. These electrons हिसाब तो बराबर होना है. So we'll see reaction at cathode. Reaction at cathode. What is cathode? It is the electrode where reduction happens. Okay, sorry, where reduction happens. And what is reduction? Reduction is rig. Reduction is gain of electrons. This video you can later save also, okay? Reduction is gain of electrons, or if possible I'll put up on YouTube and give you. Reduction is gain of electrons. So PB, who is going to gain electron? A person who gains electron. Everyone wants to become neutral. A person who is deficient in electron gains electron. Now this fellow needs 2 electrons. Where does it get the 2 electrons? Where it gets the 2 electrons which were released at anode. So those 2 electrons were floating. So it takes the 2 electrons and becomes Pb. Now this is solid lead metal. And this lead metal will form as deposits. Where it will form deposits? On the negative electrode. And now let's go back to your book diagram and see whether we have covered everything. See, we have covered everything. The leads are going to go, okay, they have drawn it on left hand side, right hand side. I have drawn the other way. Doesn't make a sense. Lead are going to go to the negative, and this is gone. Any question here? This is study of electrolysis of a molten salt. Then we will see electrolysis of a salt, of a electrolyte, which is a solution. Then we will see a salt solution. The most complex is salt solution. यहाँ तो कोई लफड़ा नहीं था. देखो क्यों लफड़ा नहीं था. Here why there is no लफड़ा, you know, because the job is very easy. You are dealing with only one electrolyte. तो आपके पास दो ही आयंस आए, एक प्रकार के दो आयंस, one type of two ions, and the example is very simple. Positive goes to negative, negative goes to positive. My question is, see, where are we heading to? We are heading to study something like this, which we will study, not now. हम लोग इसके बाद क्या करेंगे, सोडियम क्लोराइड लेंगे और इसको हम बनाएंगे aqueous. Means this will be dipped in water. You will have sodium ion, you will have chloride ion, you will have water will also split as HOH minus. तुम्हारे पास दो टाइप के anions होंगे, दो टाइप के cations होंगे. Who is going to catch the bus? And why? Why does the other one is not able to catch the bus? Why only preferential ion transfer happens? This is where the story is heading. So right now we studied only electrolyte, molten. Now we will study an electrolyte which is a solution. Okay, we'll study an electrolyte. Kitna time hai? 23. Are you fine to observe another 5 minutes, or if not, okay na? Chalo. So ek cheez dekhte hain. So this part we have done. Let's now see our next part, which will be that we will take up. Now see in your book there's a lot of, you know, there's a chart they have given. Let's discuss this chart also. 1 minute, huh? Let's discuss this chart. Okay, let's see this chart. See children, right now the type of the electrolyte that we took was lead bromide, but please understand the form in which lead bromide was taken, that is more important. Lead bromide was right now taken in molten form. That means you made sure that no other type of ions are there. Iska matlab, if you take sodium chloride in molten form also, you are going to get sodium and chlorine. If you take potassium iodide in molten form, well, then also I'll get these two. These are, if you take them in molten form. Copper bromide, only these two. Zinc chloride, only these two. Aluminium oxide in molten form is known as cryolite. Okay, aluminium oxide, this is a very, very energy intensive process. I mean, I've seen this personally with my own eyes. So very nice to watch. Overnight you'll see, you know, from molten aluminium comes up, and this is when you are doing with molten. Question arises, इन्हीं का अगर मैं solution बना दूं पानी में deposit करके, तो भी क्या यही निकलेंगे या कुछ और निकलेंगे? That is what is the question that we are trying to answer. Okay, now so half equations you should know, ionic equations showing the separate oxidation reduction happening at cathode and anode, and half reactions can be added and they will give you the complete reaction. Okay, now let's say we take the example of something called electrolysis of dilute sulfuric acid. Thoda 5 minutes, we'll just give an introduction and then maybe possible we'll leave it, don't worry, so that you are left with a thought process. Okay, let's see this setup. This is called the dilute sulfuric acid, electrolysis of dilute. Now let us go by our understanding so far. Our understanding says you can't electrolyze sulfuric acid directly, you have to make it dilute. That means out here now the game is changed. The game is changed to what? I have dilute H2SO4, which means I would expect H2SO4 to split up as 2H plus SO4 2 minus. So I get a this, and I'll also have water in it, which is H2O, and water usually splits up as H plus and OH minus. ये सब हमको देखने को मिलेगा अभी. So what type of, how many types of cations do I have? I have only one type of cation, one cation, and I have got two anions. Try and understand. I've got one cation and I have two. Now this can be seen, our human eye can actually take this and see this under two processes. One is, you can call this as electrolysis of dilute H2SO4. You can also call this as electrolysis of acidified water. कोई फर्क नहीं पड़ता है. Have you understood? Dilute sulfuric acid means sulfuric acid containing some drops of water, and acidified water means water having acid present in it. Both mean the same. I will discuss this in detail next class, don't worry. But what you need to understand here, this is now different from the previous case. Sulfuric acid will dissociate into H plus and SO4 2 minus. Water will dissociate into H plus and OH minus. Means, if you look at the type, if you look at, sir, what are the cations that I am getting? Well, the first one will give you 2H plus and the second one is going to give you H plus. Both are same type. Same type. Sir, what are the anions that I am going to get? The first one is going to give you SO4 2 minus. The second one is going to give OH minus. Different. So you have got 1, 2 and 3. But after the reaction is complete, you will see that only hydrogen gas is coming out and oxygen gas is coming out. That means ये वाला जो है ना, it remains in the electrolyte. ये बाहर नहीं आता है. So there must be some preferential treatment that some ions get. Why that preferential treatment happens? So this setup is also known as a Hoffman voltmeter. This is actually used for voltage study in higher classes. So we'll break out here right now. इससे ज़्यादा करने से you all are already frustrated. Okay. So we'll break here. From next class we take up on electron.